Hello, this is Kwang Lee. Today I'm going to go over the homework 7, what I learned from the videos about machine learning shallow learning tutorial. So this is the Colab. Colab is an online version of Anaconda platform. It's to upload the file to the cloud to be accessible from everyone that has access to the internet, and it allows us to do Python and packages stuff behind the scene. And from the first video, it was explaining how to read in a basic data set and perform the data cleaning operation and generating several machine learning models to make prediction based on the given data set. So this is the first thing uh, that the lecturer showed us. So there's a table of contents of this lecture template, and this is the place where we can find the words, and this is the file we can check. And so we have all the document the professor given us here, and first uh we need to load and initialize the data. So so we import the drive and mount it like complete like we successfully mount the data, and also copy the data sets. It says completed. And so we import the pandas by writing this Python code. The version was 2 point, let me run this right now. Oh, it's not showing here, but the version was showing that it was like 2.2.2.2.2, and uh, this lines of code wrote the data sets from the Google Drive, and after that we print the basic stats here from the uh, file called iris.data, and we print a stats on non-numeric features. So let me run this code here. Oh, let me. Yeah, so as we can see, there's a class and count unique, top, and freq. And if you run this lines of code, it prints the unique labels here. And CM stands for confusion metric. So DF here is the data frame in pandas. Is a it's a two-dimensional array, and now uh we're going to encode the string labels. So in this code, what this code is doing here is set the petal ranks to less than or equal to the 6. That means we can like see the 11 values, and for this code n equals 10, that's showing the first 10 values. So there's like 10, and after that it's a randomized data. So for this, in order to do this randomized data, we import the numpy as np. We import this one, and after we import that, we were able to use the np. So we used np here. So we randomize the ordering of all samples. So if we run this, uh, mm, it was like randomizing the number, and after we run this one, So save the randomized data to file. So if we click the file, there's a file called iris randomized data. So this is the new one. And now for this section, pulling out features and label data. So we created a new blank data frame using df selected equals pd.dataframe, two-dimensional data frame, and fe uh, features for like support length width for petals, and also make a copy of the selected features, which is this code, and return the values. And we basically do the same thing from the top here. Now it's separating data into training and testing sets. So uh, in here we need to use the cross validation. So what cross validation is, we can use all of our data for both training and testing. So in this code, we're using 80% for training and 20% for testing. And yeah, so 20% for testing. And I set the num CB false to equals to 5. And we also run this code as well. So we choose the first number, choose the first percentage example for training, and we use the mass here, so we need to import mass. So if we go up, import the library mass, and we get all the example. We're gonna use this later, so we get the uh data frame features all in this code training and this code validation. Okay, now it's the part of the displaying the summary. So we print the summary of the data, the split. So now as you can and so this is some display summary of feature data. So we needed to import the IPython display. So if you go scroll up from the import part, yeah, we import the IPython from the display. Oh no no, import the display from the IPython. And so now as we can see, there are 150 total example are used, and 120 uh is for training, which is 80%, and 30 for validation, which is 20%. And by writing this code, it shows the data chart here, which is the training summary and validation summary, and also target label summary and validation feature summary. And after that, it's uh, standardizing the data. And this is the printing out those charts. And if you see this standard deviation, it's all close to 1, which is pretty good. And now after that, we have like variables. So list model names, which is logistic regression and support vector classifier, and make an all empty for those 3 variables. CMS stands for confusion matrices. And now we train the data. So we import the linear model from the sklearn. And so we'll run this. And now it's time to make a prediction. So with by writing this code, now we have the prediction model here, and for the actual like values. So as we can see, it's all the same values. Now generating the confusion matrices. So as you can see, for I in range, length of uh list model names, confusion matrix. So this is the X value and this is the Y value. So in order to use this one, import very we import it, which is which is no, not this. Yeah, here for confusion matrix, we import confusion matrix from the sklearn metric. And also this model CM data pen has a value of CM. And now it's the displaying basic summary. Uh, yeah, this is all the code to we wrote to print. So as you can see, there's a cursive 100, 100, 100 for this time, but these values are keep changing because of the random numbers. And this is printing out this displaying this confusion matrices. So yeah, this is the chart that we got it from here. In order to use this lines of code, we import uh, this one, pretty plot confusion matrix from confusion matrix pretty print, which is this file. And we get the result like this, predicted and actual, and also predicted and actual. Yeah, and starting from the beginning, as you can see, those like check marks, I went through all the process. There's the check mark. Yeah, this is it. Thank you for listening to the video.